Hello and welcome to this quick demonstration video of some of the new features in MOMDYN version 1.6. You'll see these are primarily part of the design aesthetic as opposed to technical, but there are a couple new technical features I'll show as well. So starting off, I'll load in our 3-link pendulum model from our example set and derive its equations of motion. This will be pretty much the same as it always has been, but just to get us started, I'll run into that animation. So once it's simulated, we can start it moving. Rotate the model. So that's all well and good, much like what you've seen before. Something that we've recently added is this ability, if you drag on the scroll bar at the bottom, then you can actually position in real time, move back and forth in the simulation result. So that's pretty new. That should be convenient just for navigating around in your time series. The other main new feature that we've added in this version is our change to the interface on our navigation drawer. So we can see just generally a bit more of a familiar interface, particularly for Android users, using material design sort of features. Things fit a little bit better from my perspective. We don't have lines that overrun the space allotted to them. So generally, that won't really change how you use the app, but it should be somewhat helpful, or just in terms of making things a little bit more familiar for you. Another new feature, if we go into the report, and this you can see in the top, we now have a legend here. So obviously a very important thing for engineering plots is to actually label the lines that you were showing. So we can see at the top the 3 angular coordinates and the colors represented by them. Another thing, if you want to clean up your plot or isolate just individuals, you can tap on the legend itself to toggle on and off individual lines. So that helps especially down here with our generalized speeds. Tap a couple of them and we can isolate our 3rd angular rate and see some of its cool dynamics right there. All right, so now for sake of demonstrating a little bit more of the new technical interface, I'm going to jump into our classic spring oscillator type of model. We'll call it Springy. And give it the description, simple spring oscillator. Very good. I'm going to give it gravity, put it in a uniform gravity field with a gravity constant of 9.8. In the -y direction. Time duration, we'll make this a bit longer, let's say 5 seconds. And to smooth out the animation in the plot, I'm going to reduce my tolerance. There's 4 zeros in front of the 1. All right, clean slate here. And the sake of this demonstration is to show how I simplified the mass and the spring interface. So same as before, in the earlier versions, I'm going to define a prismatic joint with a motion axis of the -y. So a positive translation in the prismatic joint degree of freedom is going to point downward. And give this guy a value of 1. Hit OK. We can see here, if we close the drawer, that we've now got that vector drawn in gray and the point in blue pointing downward from our coordinate frame. And so the next thing I'm going to do is create a particle, point mass. I'll give it the name Bob. Bobbery Bob. Place it at the point A, which we just created, and give it a mass of 1. Simple enough. What I'll note here is previously to define a particle, you would have needed to first generate a parameter or a constant, give it a name, and then add that symbol in that spot. So now it's been simplified where to generate your particle, all you have to do is put in the number, whatever you want it to be. So there in green is our particle at the bottom. And next thing, I'm going to go into our loads interface, go down to our translational spring. I'm going to add one that links the origin to the created point A. Give it a stiffness value of 50 and an equilibrium length of minus 0.5. So the equilibrium length is going to be half the initial length of the spring. So now we can see in gold the spring that we just created. We'll animate this quickly. And now we can see that nice bouncing up and down motion of the spring mass. And going into our report, you can see nice, pretty linear sine waves in our plot view. On the top here, you can see the initial value of h of a is 1 as we specified, and oscillates between about 0.4 and 1. So because of the equilibrium that of minus 0.5, it's not oscillating about 0, but it's not quite oscillating about 0.5 either because of the effective gravity. So there we have it, a fairly simple model demonstration, but the hope is that new method of defining the particle and the spring should save you some time in your own modeling. So that's all I've got for today. Hopefully you guys will like this new interface. Please share this with your friends and peers in your engineering school or profession, and have a great day.